Integrals involving fractional part are always beautiful, and so is this problem. Integral from 0 to 1, fractional part of ln of x to the power m dx. Proposed by Ovidiu Furdui from Romania in School of Science and Maths Journal. Let's solve this problem. And please note that m is greater than 1. This will be useful later on, since for less than 1 there will be some problems. Okay, fine. Now how do we simplify this integral? We can basically let y equals to ln x, and that simplifies it. And we get e to the power y equals to x, and e to the power y dy is equals to dx. Now we will have integral from minus infinity to 0, fractional part of y, and then e to the power ym, and dx equals to e to the power y dy. Okay, now next thing will be just to group the powers of e to the power ym plus y dy. Okay, what's next? The next thing that we can do is, so about this fractional part, the fractional part is basically number minus its floor function, and floor function is just rounding down. So let's say if it's 2.9, that will just be 2. Let's say if this is minus 1.1, that will just be minus 2. Just round down the number. Yeah, and so basically if there's fractional part of 1.1, that's just 1.1 minus 1, so 0.1. If there's fractional part of minus 1.1, that's just minus 1.1 minus 2. Yeah. So that's just 0.9. You can now have the idea over here. And one of the ideas that we invoke during fractional part integrations is, basically let's say if we have integration from a to b of fractional part of x dx. In this case we can simplify this integral by the following notation. Let's say if we can let the sum go from n equals to a to b minus 1, integrate from a to a plus 1. This way integral goes from a to a plus 1, and then when n equals a plus 1, from a plus 1 to a plus 2, from a plus 2 to a plus 3, and so on, and at last we have from b minus 1 to b. So basically by the linearity of integral operation, so it will cover the integral from a to b. And yeah, and also by this note, when there is this notation, now we can just write x minus a, because a will just be the gif of x. Yeah, because it's the round down integer for x and dx. So this is the benefit. Now we will apply that to this problem as well. But here's the limits are from minus infinity to 0. So what we can do is we can take the sum from n equals to 0 to infinity, and let the integral be from, let's say when it's 0. Okay, so basically we need integrals from, okay, let me show you what do we need. We can break it to integrals from let's say minus 1 to 0 plus minus 2 to minus 1 plus minus 3 to minus 2, and this goes in. Yeah, we need to break it in this form. So basically from 1 to infinity, and for this as well, basically minus n minus 1 to minus n. So when n is 0, we have minus 1 to 0. When n is 1, we have minus 2 to minus 1. This one, n is 2, minus 3 to minus 2. So it covers all of the integrals. Yeah. Okay, let's do this. And then we have e to the power m times y plus 1 dy. Now this has simplified quite a lot, and now there's no fraction part, and now it seems like a doable integral. Yeah. So we have sum from n equals to 0 to infinity e to the power m times y plus 1 by m. Is it? But did I miss something? Have I missed something? Oh, I forgot to include the fraction part of y over here. Sorry for that. So basically over here, I also need to mention the fraction part of y. So basically the now let's say when x is in between -1 to 0 over here, the fractional part will just be x minus this integer over here in the downside. Yeah, so basically the fractional part will be y minus this integer over here, minus n minus 1. Okay, and then e to the power ym plus y dy. I'm sorry for this. Okay, so let me just like erase this over here and then write it properly. Yeah, because congestedness doesn't really look good. Okay, now let's do it. Also, let us erase this as well. Okay, so but now it's fine. Y minus n minus 1. So y minus z of y, and then e to the power y times m plus 1 dy. Yeah. Now we have sum from n equals to 0 to infinity, integral from minus n minus 1 to minus n. This is y plus n plus 1 e to the power y times m plus 1 dy. Okay, now we can use integration by parts. Yeah, sum going from n equals to 0 to infinity, and then let's u integral of b is e to the power y m plus 1 by m plus 1 minus integral of derivative of u is just 1 and its integral will be e to the power y m plus 1 by m plus 1. Now I can integrate this again in the same step itself, and just that there will be m plus 1 square in denominator, e to the power y m plus 1 by m plus 1 square. And note that this is from minus n minus 1 to minus n. Okay, so now we have sum from n equals to 0 to infinity. At minus n this will be just 1. Yeah, and over here minus m plus 1 and then n by m plus 1. Okay, and minus 8 minus n minus 1, this is just 0. Okay, fine. Now over here at minus n this is e to the power minus m plus 1 n, and at minus n minus 1 that will just be minus e to the power minus m plus 1 and then n plus 1. Yeah, and by m plus 1 whole square. Now notice that this is just a telescoping sum actually. Yeah, so basically this will just be e to the power, like first of all there's 1 and then minus e to the power minus m plus 1 times 1. Yeah, again there will be plus e to the power minus m plus 1 times 1, and again minus and this to the power 2 over here, again power 2, so they will cancel each other out. So now over here I can also use a geometric series to find the sum 1 by n plus 1, and then a by 1 minus r is e to the power minus m plus 1. Yeah, and first term is just 1. Yeah, and minus over here only the first term will remain and these others will cancel out. So e to the power minus m plus 1 times 0 is 1 by m plus 1 whole square. Okay, so this is the answer. And if you want to make it look nice, you can basically take this numerator e to the power m plus 1 by m plus 1 e to the power m plus 1 minus 1 minus 1 by m plus 1 whole square. So this is the answer. Yeah. Now if it was just fractional part of ln x, for that we can put m equals to 0. Yeah. Now let's see what happens when m equals to 0. Let's get that answer as well. So if we are just dealing with integral from, but wait, this answer was supposed to be for m greater than 1. Yeah? Okay, fine, it doesn't matter, let's input. So if it was integral from 0 to 1 ln of x to the power m dx, and m is basically 0, in that case it will be e by 1 times e minus 1, yeah, minus 1 by 1. So this is just e by e minus 1 minus 1. This is e minus e plus 1 by e minus 1. Oh, what a beautiful answer, 1 by e minus 1. Such a nice answer, yeah. So this was it. Hope you enjoyed the video. To talk about the flow of the problem. Flow of the problem was using the fractional part definition and involvement of a special kind of idea to break this into sum of integrals, and then integration by parts, and then telescoping sum and the answer. So it wasn't too hard, but it was a quite nice problem. Hope you enjoyed this problem. Thanks for watching. Look forward to seeing you in the upcoming videos too.